Hi guys, let's talk about indicators. Indicator questions have been very popular recently on the AP exam. They ask a variety of questions about acid-base indicators, so let's talk a little bit about them. There are hundreds and hundreds of indicators. Most titrations that we've done, we've used an indicator, and when the indicator changes colors, we stop. Instead of an indicator, you could always use a pH meter or a pH probe, but indicators are very convenient. Indicators themselves are weak acids, and like I said, there are hundreds and hundreds of these. If you look here, there's a bunch of them, but there's a lot more. A lot of these are organic, large organic molecules, and they are weak acids, meaning that they have some H atoms that the bond between the H and the rest of the molecule can break, and an H plus can be released. And so when it's in its regular acidic form, we typically have the proton attached, and we typically indicate it as HIN, IN for indicator, and with the H in front of it, meaning that it has its acidic proton there. When it's placed in a base, the base reacts with the indicator, removes the H plus from it, and so the indicator now is in the form of IN minus, the anion of that indicator. So usually the indicator will change colors around their pKa value. So remember that pKa means negative log of the Ka. And so if you take the negative log of the Ka and you have a pH that is equivalent to the pKa, that's when the color will change. For example, that first indicator right here, if it has a pKa of 11, that means at pH 11 it will go from yellow to red. Thymolphthalene, for example, will go from colorless to blue at a pH of 9.9 and so on. So they will change color around the pH that matches their pKa. And some indicators turn from one color to the other, like, phenolphthalein, for example, only turns either colorless or pink, right here. Thymolphthalene, that turns colorless to blue, and so on. So just two colors. Others, like universal, for example, has a whole array of colors. It has, the whole rainbow. Some other ones have, 3 different colors or something like that. So it just depends. Some of these weak acids have multiple H pluses to give off, and that's why they have multiple colors. Others only have that one H plus to give off, and so it's one color with the H plus and one color without it. So here are some sample questions that you could be asked on the AP exam. So one of the questions that are popular, they give you a bunch of indicators, and they give you the Ka value, for example, and they tell you, hey, for this titration, what would be a good indicator? So, for example, the first question here, it says, for a titration with the equivalence point of pH equaling to 8.63, what would be a good indicator that's acceptable for that? Or they could change this question. They could tell you it's a titration between a weak acid and a strong base. So you know that the pH will be a little bit higher than 7. And they ask you, what is a good indicator for that? Sometimes they'll give you the pKa values. Other times they'll give you the Ka, so you have to take a negative log of the Ka values. But let's look at our chart and see if we can answer this question. So we want something that will turn around 8.63. And so really maybe thymol blue would be good, phenolphthalein would be good, thymolphthalene would be good. So any of these really would be good answers for that titration here. So I'm just going to maybe mark it. So I'll put maybe this one, or this one. all three of those would be good. All right, next question says, which form of methyl red would be present at pH of 6? So remember, they change colors when that H plus is lost. And the two forms that they're talking about, they either want you to say that it's the HIN form or the IN minus form. And so when the pH is lower than the pKa, it's going to be in the acidic form. When the pH is higher than the pKa, then it's going to be the basic form. So let's look up methyl red. Let's find that on our chart here. Looks like methyl red has a pKa of 5.0. Here it is. And so that means if you have a pH that is lower than 5, then it's going to be in the acidic form. If it's a pH higher than 5, then it's going to be the basic form. So this is a pH of 6, and so that's higher than the 5, and so it's going to be in the form of IN minus. All right, last question here. It says, what color will thymolphthalene be at pH of 8? That's another famous question. Instead of asking is it HIN or IN minus, it would be what color? So let's look up thymolphthalene. So thymolphthalene, I already circled it, unfortunately, so it's kind of hard to see, so I'm going to erase that here. All right, so we found it. Thymolphthalene goes from colorless to blue, and it looks like it turns at 9.9. So before 9.9, it would be colorless. After that, it would be blue. So at pH of 8, even though that's a basic pH, but it hasn't turned yet, and so it's going to be colorless in this case. So this is something to kind of keep in mind for acid-base reactions. Again, these have been very popular on the AP exam.